Now we are solving exponential and logarithmic equations. If b to the x equals b to the y, so they have the same base, then x equals y. I mean, you can find that just by taking log base b of both sides, then the b's cancel, and you get x equals y. To solve b to the x equals a, you take log base b of both sides, the left side, the b's cancel, and just get x. On the right side, you get log base b of a. Or, from change of base formula, it's common log of a over common log of b. Now, there are various equations involving exponentials. There's exponential growth of a population. P naught is the initial population, P is the later future population, K is the growth rate, and T is the time. Future population equals initial population times e to the power growth rate times time. Radioactive decay. R equals R naught times 2 to the negative T over H. R naught is the initial amount of radioactivity. R is a later amount of radioactivity. T is time, and H is called the half-life. The idea is that whenever T increases by H units, then this decreases by 1. 2 to the negative 1 is a half. And so you get half what it was before H units, the time units pass by. So this halves in size every H units of time. So, for example, let's solve 6 to the power x minus 2 equals 36. What's x? Okay, 6 to the power x minus 6 equals 36. Now, so it happens that 36 is 6 to the second power. So 6 to the x minus 2 equals 6 to the second. Same bases, therefore the exponents are the same. X minus 2 equals 2, and therefore x equals 4. And that solves this. 5 to the 4x equals 1 over 125 for what value of x? Now again, we write this 1 over 125 is a power of 5, namely 5 to the negative third. So 5 to the 4x equals 5 to the negative third, and therefore the exponents are the same. 4x equals negative 3, dividing by 4. X is negative 3/4, negative 0.75. Here is 13 to the x minus 1 equals 2 for what value of x? All right, we'll take log base 13 of both sides. And on the left, you just get x minus 1. On the right, you get log base 13 of 2. And that's common log of 2 over common log of 13. To solve for x, we add 1 to both sides and get x equals 1 plus common log 2 over common log 13, which after a brief consulting the calculator comes out to approximately 1.2702. Here's 2 to the power x plus 1 equals 3 to the power x. For what values of x? All right, here. Let's take common log of both sides. Common log of 2 to the x plus 1 equals common log of 3 to the x. Then the exponents, x plus 1 comes out to multiply here. This exponent here comes out to multiply here. So x plus 1 log 2 equals x log 3. At this point, it's basically a linear algebra problem, at least as far as x is concerned. Okay, first we distribute the log 2. X log 2 plus log 2 equals x log 3. All right. Transpose x log 2 by subtracting it from both sides. Get log 2 equals x log 3 minus x log 2. Or log 2 equals x times log 3 minus log 2. Dividing by log 3 minus log 2, you get x equals log 2 over log 3 minus log 2, which comes out to about 1.7095. Here we have e to the 2.9x equals 4.5 for what value of x? All right, we take log base e, natural log of both sides. The left side is 2.9x, the right side is common log, not natural log of 4.5. Then isolate x by dividing both sides by 2.9 and get x equals log of 4.5, natural log of 4.5, that over 2.9, which comes out to be about 0.5186. To solve 15 equals 9 to the x plus 2, what to do? Well, take log base 9 of both sides. On the left, you get log base 9 of 15. On the right, you get log base 9 of 9 to the x plus 2. The 9 is canceled, just leaves an x plus 2. Now this log base 9 of 15 is common log of 15 over common log of 9. and subtract 2 from both sides and get x equals common log 15 over common log of 9, all that minus 2, which is about negative 0.7675. We have 2/3 to the 6 minus x equals 8 over 27 for what x? Well, okay, 8 over 27 is 2/3 to the third power. So 2/3 to the 6 minus x equals 2/3 to the third. Same base, so the exponents are equal. 6 minus x equals 3, transpose the x. 6 equals 3 plus x, transpose the 3. X equals 6 minus 3, so x equals 3. Here's a very similar one. 2 to the thirds to the 6 minus x equals, now it's 16 over 81. All right, instead of 8 over 27. Well, okay. Now, okay, 16 over 81. Now, that also is a power of 2/3, namely the fourth power. So 2/3 to the 6 minus x equals 2/3 to the fourth power. Same base, therefore the exponents are equal. 6 minus x equals 4. So transpose the x to the right, 6 equals 4 plus x. Transpose the 4 to the left by subtracting, 6 equals x. X equals 6 minus 4. So x equals 2. All right, so this one at x equals, is solved by x equals 3. This one is solved by x equals 2. Now here we have. Now we'll end off with a couple of half-life problems. So thorium-227 has a half-life of 18.4 days. How long does it take 80% of its sample to decay? The formula is a radioactivity formula. Later radioactivity equals initial radioactivity times 2 to the power minus T over H. T is time, H is half-life. Okay, if 80% of the sample decays, then only 20% remains. So here the radioactivity is 0.20 R naught. R naught is whatever it is, minus T what we'll find. H is 18.4, we put that here. So here we go, 0.2 R naught equals R naught times 2 to the negative T over 18.4. Cancel the R naughts, it does not matter how much the original amount of radioactivity is, it's the same half-life. Same timing. So 0.2 equals 2 to the negative T over 18.4. Okay, transpose the 2 by taking log base 2 of both sides. On the left is log base 2 of 0.20. On the right, the exponent cancels, we're just left with minus T over 18.4. Next, to isolate T, we multiply both sides by minus 18.4. I'll leave T on one side, and on the other side is minus 18.4 log base 2 of 0.20. And this, by the change of base formula, is common log of 0.2 over common log of 2. That times minus 18.4 gives you the value. And so minus 18.4 log 0.2 over log 2. And turn the crank, out comes about 42.7 days for 80% of that sample to decay. Now here we have one, I think a really cool one. Carbon dating. Everything you have, let me start from the beginning. Carbon on Earth is naturally slightly radioactive. That's because carbon dioxide high in the atmosphere will sometimes be hit with cosmic rays, and then by various decay processes. Actually, it's nitrogen that turns into carbon, and specifically carbon-14. This is a radioactive substance with a half-life of 5,700 years. Now, everything, carbon dioxide is all over, so it gets everywhere. And it gets into all plants, and therefore all animals. So we're all slightly radioactive. Not very. 5,700 years is a long half-life. Now, okay, the thing is that when an animal is, say, living and eating, its carbon-14 is in equilibrium with its environment, but when it dies and its bones get buried, those bones don't exchange carbon with the environment, so it simply decays away. So, okay, here we have a bone fragment. It turns out to have 60% of its initial carbon-14 content. How old is it? So again, R equals R naught 2 to the negative T over H. R is 60% of R naught. 2 to the minus T over H is 5,700 years. So 0.6 R naught equals R naught times 2 to the negative T over 5,700. Cancel the R naughts. 0.60 equals 2 to the negative T over 5,700. Log base 2 of both sides. So log base 2 of 0.60 equals negative T over 5,700. multiply both sides of the equation by negative 5700, and you get t equals negative 5700 log base 2 of 0.60. And again, by the law of change of base formula, this we can rewrite as negative 5700 common log of 0.60 over common log of 2. And this comes out to be about 4,200 years. So that's how they use carbon-14 to date things. Okay, I think that covers it for now.